Hello, welcome to the happiness track again. I am Maya and I work at Scala. I will accompany you during the next four talks introducing our great speakers, but you can also catch me on a special chat during the next couple of hours. Now let's meet our hero. Active in a Scala community since 2014, the creator of Coursier and Almond. Definitely the person who made the Scala users world much more comfortable and easier. Please welcome Alex Archambault. Alex will also answer all of your questions just after the talk. Alex, the stage is yours.
All right. Right. Can you see the slides or?
Yes, we can.
Okay. Good. Okay, so thanks for the introduction and thanks everyone for attending this talk. So we are going to discuss how to set up your environment for Scala development in a reproducible way using Coursier. All right, so a little bit about me. My name is Alexandre Archambault. I'm now working as an independent software engineer. Before that, I was working at the Scala Center. And in spite of being independent, I'm still working regularly with the Scala Center. And in particular, many of the features that we are going to see in this talk were actually funded by the Scala Center. So I'm also active in open source. So I'm the original author and maintainer of Coursier, which initially was just a library to manage dependencies from Maven and Ivy repositories. It's now used by SBT, by Mir, by Bazel, and a long time it evolved and got more higher level features, so to say. Namely, it can now manage applications or JVMs, not simply Maven dependencies. So I'm also the original author and co-maintainer of Almond, which is a Scala kernel for Jupyter. And I have significant contributions in Shapeless and in Ammonite. And I also have smaller projects like Plotly Scala to do plots in Scala or CaseApp to parse command line arguments. All right, so in this talk, we're going to talk about Coursier and more particularly about its CLI. So its CLI is called CS here. And CS comes up as a binary. So it's a native binary. It's generated thanks to GraalVM. So it's a GraalVM native image. And thanks to that, it has no dependencies. I mean, it doesn't need a JVM to run. Its only dependencies are, I guess, C or C++ standard library things, which are almost always around. So we can basically say that it has no dependencies. It only takes one command to install it. So on Linux or on Mac, we can just use a command such as this one. On Windows, you can just download its executable and double-click it. And thanks to GraalVM, it now supports 4 platforms, so namely Windows, Mac, and Linux on x86 64-bit processors. And more recently, it got support for Linux on ARM64. So that means that if you have a Raspberry Pi 4, you can now run CS natively on it. So the Coursier website has more details about how to install the CLI. And in a few minutes, I'm also going to give you some more resources that explain how to install and use CS. All right, so just to give you a small glimpse of what CS can do, CS is basically made up of subcommands. So it has a low-level commands somehow, which usually take as input Maven coordinates such as these. So these are coordinates made of an organization, a name, and a version. And the Coursier CLI also has high-level commands, which deal with higher level things like applications or JVMs. So let's have a quick look at these commands. All right, so I'm going to log into this machine, which is actually a Raspberry Pi 4. And this machine does not have Java installed. It does not have CS either. And so we're going to use coursier to, we're going to review its command and install Java and some applications along the way. So let's grab the coursier launcher. So I'm going to go to the GitHub release pages of coursier to, so yeah, this support for this architecture is quite new. So it doesn't have a short URL yet. So I'm going to the GitHub release pages of coursier to, so let me show you. Right, so I'm on the GitHub release page of coursier, and I'm going to download this executable. So I'm copying the link. All right. And back to the terminal, I'm going to download this as CS. All right, so, okay, it's downloaded. Let's make it executable. And we can now run CS. So now let's install this in our path. So for that, I'm going to ask CS to install itself this way. So this is downloading the CS launcher again, but via the coursier cache this time. Okay, and it complains that the directory where the launcher was put is not in the path. So let's put this directory in the path too. Use this command. All right, so this command updated some profile files. So let's log out and log in again. And we should have CS in our path, right? Let's remove the launcher we downloaded. And, okay, we still have CS. All right, so let's have a quick look at the CS commands. I won't be very thorough here. I will give you more resources in a few minutes. So the CS command line has a first command called complete that completes Maven coordinates. So for example, let's say we want to grab the Scala 3 REPL, but we don't remember what exactly are its coordinates. So we can ask complete to complete this for us. So here it proposed it should be something like Scala lang. Okay, it's here. So we're going to add this to these coordinates and ask for more completions. And all right. So we're on the Scala 3 REPL. So let's download the Scala 3 compiler. Say we were going to use this version. All right, and try to compile this again. Okay, so let's pick this version here because the others are nightly. At least. And all right, so now we have the full Maven coordinates of Scala 3 compiler. So now let's try to resolve this using the resolve command. So if we do this, okay, this is downloading some metadata files, PAM files, and we get a list of dependencies, which are the dependencies of Scala 3 compiler here. Next, we can use the fetch command to fetch the class path of this dependency. So let's call fetch with it. And now it's downloading jars, jars here. And it lists the jars of this dependency here. So another command that we have is the launch command. So I mean, we complete dependencies, we resolve them, we fetch them. Now we can launch them. So let's try to launch this as is. And okay, so we didn't have Java installed. So the launch command is downloading a JVM for us. and we just use the Java binary in this JVM. Okay, so it should be unpacking the JVM now. All right. So so what happened here is we didn't so there are many main classes in this dependency here, and of course the default one is not the one we want. So we have to specify the main class that we want to run. So it should look like this. So let's try this, and this will not be enough because as we are running the Scala repo outside the Scala archive, we have to pass it an option such as this one. And now it should work. Okay, so we have the Scala repo here. Okay, so this was the launch command. So now we can have a look at the higher level commands. The first one is install. So we saw install a few minutes ago to install CS itself. This way. We can actually use it to install other commands like let's install Scala FMT. So it downloads the class path of Scala FMT, right, and it wrote Scala FMT. So now we have Scala FMT in our path. And so it is in the path, but Java is not installed. So let's use another high-level command, so the Java one, to install JVM. So we're going to use the default JVM. So we just ask to set it up this way. And okay, it edited profile files here. So we're going to log out and log in again to be able to run the Java command. Okay, now we should have Java in our path. All right. So, and now if we try to run Scala FMT, it should work. Okay, it does. So, of course, there are no files to format here, so it complains. So these were the install and Java commands. We also have a setup command that basically wraps the install and Java commands. So what setup does is it installs a JVM if none is found on your system, and then it installs some basic Scala applications if they are not already installed. So let's run it. So it found a JVM, so it doesn't try to install one. It found that the directory where launchers are put is already in the path. And next, it tries to install some Scala applications. And as support for this architecture is quite new, it fails at some point, but it already installed a few applications. Right, so this was the setup command. And lastly, so we saw the install Java and setup command to really install things on our system, to really put things in the path. But now, let's say we are writing a script, a bash script, and we want to call an application like Ammonite, for example. What we can do is, instead of installing Ammonite ourselves and messing with the possibly already installed Ammonite, what we can do is launching Ammonite with just a launch command this way. So the launch command actually also accepts applications and can run them. So let's do this. All right. And launch also accepts JVM flags. So if we want to use a particular JVM without really installing them, without making it the default on the machine we are on, we can just pass this flag, this option to launch, and it's going to use this JVM. It was not already downloaded, so this is downloading. So this is adopt OpenJDK 11, and it's going to start Ammonite with this JVM. So okay, it's downloading. And okay, so it's a Raspberry Pi, so it takes a bit of time. Okay, Ammonite is starting, and it's using Java 11 here. All right, so this kind of command is quite handy from scripts. For example, if you want to start applications without messing with already installed ones or without messing with already installed JVMs yet. So let me go back to the slides. Yeah, sorry. So yeah, we saw the SetLaunch Ammonite command, and it can be handy in scripts. Yet we are going to discuss some of the limitations of using this command as is in scripts in a few moments. So if you want to know more about the coursier CLI, there are some resources that are available online. For example, a few months ago, I wrote this blog post here that describe what the setup, reproducible install, and Java command do. If you prefer videos, Dev Inside You, who does Scala development related videos, made 2 videos about coursier. One is about setup, and the other is about the other commands. And lastly, you may have seen a tweet yesterday by the Scala Lang account about upcoming Scala 3 videos. And some of these videos are going to be about coursier. And these are made by the Scala Center in collaboration with Lunatic and 47 Degrees. All right. So let's get back to the SetLaunch command we saw just earlier. So this kind of command can be handy from scripts, yet there are things. I mean, when you see that kind of command, there are things that can make you feel a bit nervous. Like this command might work for us right now, but what if newer Ammonite versions are released in the future? Or what if newer JVM and JDK are released in the future? This command will just pick the newer versions, and this could break our scripts. And we not want that. And so what we can do to address that is, what we should want to do is to try to lock the versions that are being used here, so the Ammonite version or the JVM version, in order to make this command really reproducible. That is, ideally, we'd like such a command to always start the exact same application, so the exact same Ammonite version in particular, with the exact same JVM, so the exact JVM version we picked right now. So we'd like this command to start exactly the same versions of everything in order to be more reproducible. So in the first time, naively, what we could do is just pass a few versions to this command. So we could, for example, add an Ammonite version here. We could specify a more precise JVM ID here. Yet we can't be sure that it's enough. So this command does quite complex processing under the hood, and even I, as the author of coursier, I can't be sure. Just adding a few versions like this, I can't be sure that I didn't miss any parameter that would need to be fixed, to be locked. For example, in this command, under the hood, the Scala version ends up being picked. Like, to start Ammonite, we need to choose the Scala version for it, and SetLaunch will pick one for us. but there are other things that can change in the future and that are being used by this command. In particular, to go from the Ammonite name here to full Maven dependencies with an organization, a name, and a version. SetLaunch here uses some metadata from what we call an application channel. So it's a bunch of JSON files that say, okay, Ammonite has these Maven coordinates. There are also some other metadata related to the JVM here to go from 11 to an actual JVM name, a more precise version, and to know where to download this JVM. SetLaunch uses a JVM index, which is a large JSON file listing JVMs and where to download them. And so many changing things are actually downloaded on the hood when using this command. And so naively setting a few versions is not enough to be sure that we have a really reproducible command. So the good news is in the internals of coursier, we actually have everything to know where this kind of changing data is being used. So let's have a quick look at peek at some of the internals of coursier. So coursier has a cache module, and one of the functions of this cache module is to provide a method like this one. So this method takes an artifact as input and gives you the text content of this artifact as output. So an artifact here is just basically a URL. We'll have a look at this later. And so basically what the cache does is it takes a URL here and it gives you a string, or it can also give you a file, but here we are looking at strings. So one nice thing to notice here for reproducibility is that most of the artifacts that we get from coursier come from Maven Central, and as you may already know, artifacts on Maven Central are immutable. That is, if we look, for example, at an artifact such as this one here, so we have the URL of a pump file of the Scala library. This file does not change and will not change in the future. So Maven Central is we can't overwrite files on Maven Central, and we can't delete them either. So basically, if we use as input here artifacts that come from Maven Central, we'll always get the same output here. So in a way, using only Maven Central artifacts, this function here becomes a pure function somehow. So given the same artifact, it will always give the same text content as output. So of course this is modulo. The string is wrapped in an F here, which accounts for possible network failures, but also the time delay it takes to download this file or to read it from disk. But overall, the idea is that using only Maven Central, this function here is a pure method. And so when we use this in the internals of coursier, if you only use immutable artifacts, such as the ones from Maven Central, we'll have, we get the whole resolution itself becomes reproducible. So, it's a really nice result. This is how when you use coursier in your build tool, like in SBT or in Mill, and you add a dependency, when you add a dependency, you want to always get the same jars, be it on your local machine or in your CI, and what guarantees that is the fact that we are using immutable artifacts, which give us a cache that behaves as a pure function. So now, how does this break in the command we saw just before? But this breaks because some artifacts are not immutable. So I guess we all know of snapshot artifacts, like the ones from Maven Central. Snapshot artifacts that we may overwrite. But even on Maven Central, there are changing artifacts, such as version listings. So this URL here is a version listing of the Scala library. And when new Scala versions are released, this file is updated. And so in itself, this file is not immutable. And to handle this, the cache of coursier, deals with faces two cases. So either the processing coursier tells upfront whether a file is changing or not via this field here in artifacts, and so the cache itself then reacts to this by so if a file is not changing, if we have a local copy of it, for immutable files, we are going to use that local copy straight away and not do any network I/O. Whereas for changing files, even if we have a local copy of it, we may still want to check if newer versions of it are available, and so this is why in the internals of coursier we have this field here, and we need this field so that the cache handles correctly changing files such as this. Right. So a good news is thanks to this, we know really in the core layers of coursier when non-immutable artifacts are being used, and so we know precisely where and when some non-determinism can be injected in some processing made by coursier. So we can use this to make the command we had just before more reproducible. So let's have a very quick look. I'm going to share my terminal. All right, so now you should see the terminal. So the coursier CLI now has an option called log changing, which will print a line every time a changing artifact is being checked. That means every time some non-determinism is injected in some processing done by coursier, this will print a line, and we'll have more details about what happens. So let's try this. Okay, so it printed many lines here. So what we see here is this references the IV2 local repository of this machine. So what we're going to do is to stop using this repository. So I'm going to pass this option here. So here the -R is for to pass new repository. The exclamation mark means we want to override the default repository, and we pass central, just Maven central, as a repository. So let's try this again. And so now Maven central is the only repository used here. So we have less output. So these are all the files, all the changing files that inject non-determinism in this command. So let's have a quick look at them in order and see if we can manage to work around these files so that none of these, so that we can let's see if we can manage to have these files not being used in this command. So let's look at the first one. So this is when, so right now, guessing the options that are needed in order to not use all these files requires a bit of know-how. So luckily, I know coursier, so I know the options to pass here. In a few minutes, I'm going to discuss how we can make this better, how we can make this easier to use for people that are not familiar with all these coursier options. So the first artifact here is IO get coursier apps. And this is the application channel of coursier. This is how coursier goes from an application name Amlite to actual Maven dependencies. So in order to fix, to lock this, so here this was a version listing of this application channel. So what we're going to do is to lock the version of this application channel. So to know what version is being used, we're going to log the channel version. So right, let's do this. And it said it's using channel this 106. So now let's use this as an application channel. So like for repository, I'm overriding the default channels and I'm passing the new one with an explicit version. So let's check this. And so yes, it doesn't check the version listing of IO get coursier apps. So now the first changing artifact it checks is this. So this is the version listing of Scala library, and this means this command is trying to pick a Scala version. So let's fix that by passing ourselves an explicit Scala version, such as this one, and see what happens. All right, it doesn't look at Scala version listings anymore. So now, now it tries to look at this. So this is an Ammonite version listing, and so we can work around that by passing an explicit Ammonite version. So let's pass this version. And okay, now it doesn't check Ammonite versions anymore. So the only remaining file is this one. And this one is actually the JVM index used by Coursier to know where to download a JVM 11 here. So to work around that, I'm going to use a slightly different index, so namely the one from Coursier here, called, so it's aliased as CS, so let's use it. So now what is being downloaded is not a GitHub URL, it's a Maven Central URL. So what happens here is this command tries to list the versions of IO get Coursier JVM index. So it's a new index, so it's downloading a different JVM. I think it's a newer JVM 11. All right. Okay. So it's starting right. So in order to work around that, just like for channels, we are going to log the exact version of IO get Coursier JVM index that is being used. So log JVM version, JVM index version. All right, and so it says it's using this JVM index version. So now let's use this as a JVM index this way. And okay, now no changing files are being used when we run this command. And so that means this command here is fully reproducible. That is, if we run it again in the future, it will still pick the exact same JVM. It will run the exact same Ammonite version using the exact same Scala version. And so that, I mean, now we have a fully reproducible command. Right, and now, if ever we were to change that command in the future, if we want to make sure that that we don't accidentally make it non-reproducible, we can pass this option to this command. So -m is some cache-related parameters, and pure says that pure forbids to download changing artifacts. So when you pass this option, only immutable artifacts are allowed. So let's have a look. So it should work, of course. And now let's see if it does break when we use changing artifacts. So let's stop using this JVM index. And yes, it breaks. So it says error while getting a changing artifact. Right, so we have these two options, log changing and pure, to help us make coursier commands more reproducible. And we don't have to rely on guesswork to know what options to pass. I mean, thanks to these options, we know exactly when changing things are being used, and we know exactly when non-determinism could have been injected. All right, so let me get back to the slides. So yeah, there are a few limitations to this approach. So here we worked around the non-determinism coming from changing artifacts. Of course, if you use a different coursier version, some algorithm in coursier might change, so you might get different results. The OS might give you slightly different results, so you should get a different JVM, but sometimes the OS can change things in the resolution. There are implicit inputs in resolution that rely on the OS. And also, I can't explain that in detail here, but the JVM cache of coursier can introduce some non-determinism. I mean, depending on the state of the coursier cache, the JVM-related features may behave differently. This could be addressed, but right now, this is a possible source of non-determinism. Okay, and so overall, this still required quite a bit of guesswork to work. Like, you had to go from the URLs to the right options for the CLI, and it's not very, usually not very accessible to people that are not familiar with the internals of coursier. And so if you are interested in making that better, if you want to help make that better, so you can help. So if you would like, I guess if you are a company and you would like to fund that effort, I think it's a few weeks of work to have options such as we can pass something like -- lock options to a coursier command and have it print exactly the options that we need to add in order to make a command more reproducible. So I think in a few weeks of work, we could have this working. And so I've written down in more details what this would entail in this post. So if you are interested in funding that, please do get in touch. Right, so that's it